Hello, I'm Jack Drury,
Hello, my name's Sergio Alvarez.
and yeah, this is going to be a really exciting set of videos.
Yeah.
We're talking about our new digital IM system, which is your baby, right? This is your thing.
Yeah, we've been working at this for quite a while, so we're excited to finally talk about it.
So we had a chat earlier.
Yeah.
We were actually on site yesterday using this, which was really exciting, and I just felt like if you come from an analog IM world, this is a completely different beast of products, used in a completely different way. So we wanted to start just by going through what makes this different and how your workflow is going to change. So the first question that I've got for you is, how is digital different to analog? In terms of RF?
So the two main things with a digital IEM system. One, with digital RF, you get much better spectral efficiency. You can get more channels on air. And so one of the key aspects is, finally having our RF engineers say yes to more complex projects, right? And then additionally, for the first time, we have an IEM system where the audio quality isn't affected by the RF, right? The audio quality remains consistent over distance, right? Because in a traditional analog FM system, right, the audio quality is kind of tied to the signal to noise ratio. There's things like companding and squelch circuits, right, where that all goes away with digital RF. Kind of like on the mic side, right, it's audio that gets coded into digital data, and then that gets decoded, right? So you have clean, consistent audio all the way to end of range.
So in a normal PSM 1000 FM system, when the signal starts to go down, you'll hear the noise creeping in, but you'll get that kind of distance. It starts to sound not so good. In this world, same as in Axient Digital mics, it's going to be perfect up until the point that you're disappeared into the noise floor, and then it's going to cut out, right?
Right, and some of the other things that people are excited about is kind of the very low noise floor, right? No more of these kind of like erratic, quick RF dropouts that are just caused by like natural analog FM. It's completely clean. It's almost kind of very new to customers of like, they don't even know if it's on or off.
Yeah,
right?
because in an FM system, you're just listening to raw UHF, right?
Right.
Just with some modulation in it. Whereas, same as Axient Digital, I guess this is taking that modulation, that RF, and it's going to pull the data out of it and then turn it into audio, right?
Very transparent sound.
Very, very exciting. And no companding either.
That's
huge.
new for people.
Yeah, so all of that dynamic range is going to come back. You can start to, there's less coloring of the sound, I guess, without the compander.
Yeah.
So that's a lot of audio side. You mentioned the RF side, and that's just a huge stuff we're going to get into in some later videos, a huge topic. But the big question for me right now is, what are we going to be able to do with this system from an RF perspective that we have not been able to do with analog?
So another major headline of a digital system is a feature that we're calling spatial diversity. And this idea is being able to send a duplicate RF signal on the same frequency, but on a second transmit antenna. So what this effectively does is provide true digital diversity on the transmit side of the equation, right? Wireless microphones for many years now have had the luxury of two properly set up antennas, right, with true digital diversity. And now we're finally bringing that to the ears. And then when you combine that with true digital diversity body pack, right, you actually have 4 discrete RF paths that are then combined, added together to provide a better overall signal.
Okay, so just to unpack that quickly, in the old world, PSM 1000, if I'm got my RF engineer hat on and I'm doing an award show and I need to get extra coverage, I need to cover a B stage, what I'm doing today is getting another antenna. I'm doing some maths, right? I'm trying to figure out how I can get it placed without too much multipath so I get dropouts. And then I'm probably not going to do it very well anyway.
Right. So what you're describing is actually what we call passive antenna splitting, right?
Okay.
And spatial diversity is not that. With passive antenna splitting, right, you're actually creating more opportunities for multipath interference, right? You have to deal with things like antenna placement and antenna cable lengths. None of that matters with spatial diversity. You can put those antennas anywhere you want, either to create separate zones, right? Or to really, what it's really designed for is to mitigate multipath interference, right? When you have RF that bounces off of walls, off of objects, right? And if they land at the wrong place at the wrong time, that's where you get these like random dropouts that even the best systems, the best RF engineers can't handle, because that's just the nature of a single antenna system.
So what you're saying is tomorrow with this stuff, when I'm trying to do that same thing, I'm not worrying about it. I'm just getting an antenna and I'm plugging it in and I'm putting it where I want it to go, and that's it.
Right, and then you plug in the second antenna, and then you get a much better RF signal.
Super exciting. So just to go down this topic another level, I've written on here, RF output power, discuss.
Yeah.
That's all that I've got. So in FM analog world, we're in a world of like 10 milliwatts, 50 milliwatts, 100 milliwatts, gives you more distance.
Right.
And that's not the case with this.
Right. In terms of RF output power, that's going to totally depend on how you're operating the system. But in general, with spatial diversity, you don't need as much RF output power because you really get a performance benefit from having two antennas placed properly apart. Things like, we're all kind of bodies of salt water, right? When you have a portable body pack on you, your body affects the RF. And so when you have two antennas strategically placed, you can kind of walk around, turn around, and not affect the RF as much.
Okay, so whereas previously to solve problems, we might have just turned the power up and kind of hope for the best, right? Which is what we were doing.
Which sometimes causes more problems with multipath interference, right?
Absolutely. Now what we're going to do is we're just going to place more antennas around at a lower power, so we're not flooding our stage with a load of energy.
Correct. And then it starts to play nicer with the other, dozens of wireless mics that you have to coordinate for.
So cool. Okay, one last thing for this video. Another term which is going to be new for users of this is WMAS.
Yeah.
So this is quite a big topic. We're going to get into it in more detail later. Just to start us off, what is it? What is WMAS?
So the way I would explain WMAS is really it's just a new regulatory framework that allows us to do things outside of the standard 200 kilohertz RF signal, right? With that, it's kind of up to the manufacturers to decide how to create that technology. Axient Digital PSM is Shure's first iteration of WMAS, right? And so powered by Shure's WMAS technology, our approach is really focused on spectral efficiency. So, for example, with Axient Digital, you can actually go up to 28 channels in a 6 megahertz TV band.
Right. So we were on site yesterday.
Yeah.
And we had, 4 antennas?
Yeah, we did it across 4 antennas because one of the new things with digital RF is that it doesn't produce as much intermodulation, right? The intermodulation that is produced is kind of a lot more buried in the noise floor. So you don't, with traditional analog FM, this is something we've kind of been educating our customer base for quite a while, is that you have to combine everything to a single antenna to reduce intermods, right? And that's just inherent with analog technology because older analog products aren't as spectrally efficient, they're not as linear, and so you have to coordinate for that intermods, and combining it helps, right? But like yesterday, we did 28 channels of IEMs across 4 antennas, both in spatial diversity, and that worked quite well.
That was amazing, actually. Okay, so if I'm going to summarize this discussion then very quickly, the first thing is everything we've told you about how this works for the last 25 years, a lot of that now isn't the case. We get excellent audio quality. We don't have the companding. We're not listening to raw UHF. We're listening to a digital audio stream. Yeah. The technology allows us to do much more in the RF space, whereas previously more antennas is bad.
Right.
Now more antennas is great, right?
It is, because you don't want to necessarily lose on passive signal loss that you normally would when you're combining.
Absolutely. So this is going to be a very different type of system to use. We're going to go through some more videos now. We'll show you what the hardware is, all the components of this system. We're going to show you some of the operational presets of this system, so different ways that you can deploy this on site. And then we're going to look at ShowLink, which is something we haven't mentioned yet. If you're familiar with ShowLink in our Axient Digital products, you're already kind of 80% of the way there. But there's a few very exciting things that it does specifically for ADPSM. Yeah. Which we're happy to get into.
It's going to make some of our engineers really happy.
Yeah, absolutely. Okay, so stick around for the next videos. Hope this has been useful, and we'll see you on the next one.